Good evening, all. Welcome to the live classes of the Bidyasagar. So last class रे हमें किसी concept discuss करते ले regarding our organic chemistry basic principle and techniques. सेही chapter ऊपर आओ किसी हमें important question ये करिवा. So हमें continue करिवा with some more question regarding this organic chemistry basic principle and techniques. Okay, so विद्यासागर क्लासेस तरफ समस्त को परिवार तरफ राखी पूर्णिमार समस्त को हार्दिक शुभेच्छा जनाऊे. आज रक्षाबंधन समस्त को हार्दिक शुभेच्छा फ्रॉम विद्यासागर क्लासेस. ओके, तो प्रीवियस क्लास रे गोटे होम असाइनमेंट दिया हितला. ए बोतल कंटेनिंग टू इमिसिबल लिक्विड्स इज गिवन टू यू. दे मे बी सेपरेटेड बाय यूजिंग ए व्हाट आसीबो हमरो फ्रैक्शनल कॉलम, सेपरेटिंग फनेल, वैक्यूम डिस्टिलेशन, स्टीम डिस्टिलेशन. तो एडे आंसर आसीबो हमरो सेपरेटिंग फनेल मेथड, जोथरे हमें दुईटा इमिसिबल लिक्विड्स को हमें सेपरेट करि परिबा बाय इवापोरेशन एंड कंडेंसेशन बाय सेपरेटिंग फनेल मेथड. राइट, so two immiscible liquids can be separated by separating funnel method. So answer asibo B. Okay, fine. So right, so hame start kariba ajir session. Okay, which one of the following is the strongest nucleophile? Br minus, OH minus, Cn minus and C2H5O minus. So here the strongest nucleophile is the what is nucleophiles? Nucleophiles are the electron rich species. That means they are rich in electron. Electron density is high. So, sorry. Okay. So electron density is high in case of, that is the nucleophiles. They are electron rich species. Okay, so the correct order is the strongest nucleophile is your Cn minus. So it is the strongest one. So if you see the order, Cn minus is the strongest nucleophile as compared to the Br minus, OH minus and C2H5O minus. So is the correct answer is your Cn minus, which is the strongest nucleophile, which is rich in electrons. Okay, so हमें समस्ते बुझी होची. नेक्स्ट हमें ये को जिबा तो समस्ते कमेंट करि परिबा बुझी होची कि नहीं. ओके, राइट, गुड, फाइन. तो नेक्स्ट क्वेश्चन को हमें जिबा. Strongest acid among the following is. So acidity of a acid or acidic character of a acid depends on electronegativity of atom which is attached. to acid. So CCl3COOS. So here 3 electron withdrawing group is there. So it will withdraws the electron from the C double bond O, so that releasing a proton becomes easy. But here CH3 is the electron donating group. Here the H plus removal is difficult. In case of CBr3, so the bromine is less electronegative as compared to chlorine. So in this case also, it can easily release a H plus proton because of electron negativity value. But the most electronegative value is the CF3. Okay, so CF3 is the correct answer. So if you'll see the electronegativity, F is more electronegative than the chlorine. Chlorine is more electronegative than the bromine. Bromine is more electronegative than the iodine. So fluorine is the most electronegative element, and the fluorine attached to the carbon atom, which in turn attached to the COS group, it withdraws the electron towards itself so that it can easily release a proton. So the oxygen atom becomes electron deficient and it H plus in this case. So CF3CO is the strongest acid because it can easily release the proton. So correct answer is the C option. Okay, I think समझते बुझियोची right, Sonali, right, good. So C is the correct answer. So because the electronegativity order is this, so more is the electronegativity of the atom attached to the COS group, so more is the strength of the acid, right? Okay, we'll move to the next slide. Fine. So exclusive classes coaching OUAT of online and offline provide korchi amra Bidyasagar Classes. Those who are interested, they can register the form, description form in the Google. So mobile numbers are there, we can note down and you can register the form in the Google, okay, for the online offline classes for OUAT. Fine. Okay, we'll move to the next slide. Okay, a meta-directing functional group is COH, OH, CH3, Br. Okay, which one is the meta-directing group? So, you know, which are the meta-directing groups? See, the so there are two directing groups are there. Two directing groups. One is ortho para and another is your meta directing. Okay, so any group attached to the benzene ring, if it is a electron donating group EDG, so like your CH3, OH, so these are all bromine because they are having oxygen having the lone pair of electron, bromine having the lone pair of electron. So they are the electron donating group. They will increase the electron density in the benzene ring at the ortho and para position. At the ortho and para position. So if any electron donating group is attached to the benzene ring, it will generate the negative charge at the ortho and para position. So it's a ortho para directing group. Ortho para directing group is your OH group and your CS group, CS3 group and the bromine group. Okay, but the meta directing group, they withdraws the electron from the meta directing group are the groups which are double, which is these are OH, C triple bond M, CHO, they are having multiple bonds attached to the more electronegative oxygen atom, right? CHO, COH, C triple bond N. These groups withdraws they are the electron withdrawing group. Electron withdrawing group. They'll withdraw the electron from the benzene ring. So they generate the ortho and para position, positive charge at the ortho and para position, which becomes electron deficient. On the meta position is there which is electron efficient, so they will attack, they will direct the incoming electrophiles at the meta position. So answer is your COS group, which is a meta directing group which withdraws the electron from the benzene ring. So only the meta position become electron efficient, so the incoming electrophiles attack at the meta position. So answer is your COS group is the meta directing group. Fine. COS group is the meta directing group. Okay. Yes. Fine. So I'll move to next slide. The following compound will undergo electrophile substitution more readily than the benzene. So first of all, electrophiles means what? So first of all, you know what is electrophiles? Electrophiles are electron loving species. Electron loving species. It will attack to electron rich center. जोटी इलेक्ट्रॉन डेंसिटी हाई रहबो से अटैक करिवो काहे ना इलेक्ट्रोफाइल्स आर इलेक्ट्रॉन डेफिशिएंट. Electrophiles are electron deficient. It will attack to the benzene ring where the electron density is high. Electron density is high. So now we'll see here in nitrobenzene, which is a electron withdrawing group. Nitro group is the electron withdrawing group. So it will decreases the electron density on benzene ring. Benzoic acid, that is the COS group attached to the benzene ring. It is also electron withdrawing group. It will also decrease the electron density on the ring. And the phenol, benzaldehyde, CHO group, which is also electron withdrawing group. It will also decrease the electron density on benzene ring. Okay, so phenol is having OH, oxygen is having lone pair of electron. It will increase the electron density around the benzene ring, having plus M effect. Plus M means mesomeric effect. Plus M effect because which will induce electron to the benzene ring. It will increase the electron density on the benzene ring. So the due to increase in the electron density on the benzene ring, electrophiles can easily attack to that compound. So correct answer is your phenol. So the answer is your phenol. I think correct. So answer is your phenol. Right? Well, are you getting all? So answer is your phenol is the correct answer because it will increase the electron density on the benzene ring. Fine. We'll move to the next slide. So Bidyasagar Classes providing the OUAT recording classes for more than 500 hours. So we'll get it only rupees 999. Okay. So if you are interested, you can fill the form, Google form in the description. Okay. And numbers are also there. You can contact in these numbers to Bidyasagar Classes. Fine. We'll move to the next slide. Which one of the following is true? A cis isomer has a lower boiling point than the trans. A cis isomer has a lower melting point than the trans. All isomers of the nitrophenols are equal soluble in water. All the three are correct. So if you compare the cis and trans, Okay, if we'll compare the cis and trans, cross करें. Okay. Right. A cis isomer has a lower boiling point than the trans. If you'll compare between the cis and trans, cis isomer having polar structure, they are more polar, it is less polar. Due to polar structure, they are having intermolecular attraction is high, intermolecular high, so they are having higher boiling point. They are having higher boiling point than your trans. So this one is a cis isomer has a lower boiling point. This is wrong. This cis isomer has higher boiling point than the trans. Okay. A cis isomer has a lower melting point than the trans. Right. If you will see cis and trans, trans is having symmetrical structure. It's a asymmetrical structure. Due to symmetrical structure, it will fit to crystal lattice better as compared to cis. So they are having high melting point. Trans having high melting point. Then cis. Due to asymmetrical structure, they are having low melting point. So a cis isomer is a lower melting point than the trans. This is the correct answer. If you will see the option 3, C, okay. So if you will see the option C, all the isomers of nitrophenols are equally soluble in water. That is wrong, because orthonitrophenol, that you know, due to intramolecular hydrogen bonding, the solubility decreases. The orthonitrophenol's the solubility is less in water. Okay, but paranitrophenol is more soluble in water. So all isomers are not equally soluble in water. So C is also wrong. Okay, so answer B is the correct answer. The cis isomer has a lower melting point than the trans. Trans having the higher melting point because of what? Because of symmetrical structure, it will fit to the crystal lattice better than the cis isomer, right? Fine. Okay. So answer is your what? B. Okay. So next slide, Kujiba. Which is the weakest base? Okay. Which is the weakest base? Right. So see here. In this case, which one is the weakest base? Which is a strong base? which is a good electron donor, which is a good electron donor, or you can say electron density is high. Electron density is high. So that will become a good electron donor. So that act as a strong base. So see here, in this case, the NH2 is not directly attached to the benzene ring. So there is no resonance because the nitrogen is, the lone pair electron is here. Here also the nitrogen is not directly attached to the benzene ring. There is no resonance. So no resonance. Here also no resonance. NO2 CS2 NH2, here also no resonance. But here the NH is attached to the CHO, C double bond OH and H, the so the NHCH3, the lone pair is conjugated with the double bond. So here is resonance of lone pair, resonance of lone pair, which is not available to the, which is not available on the nitrogen, which it will shift to the carbon atom due to resonance. Due to resonance of lone pair, the electron density on the nitrogen decreases. So it becomes the weakest base. It becomes the weakest base. Okay. Fine. So it becomes the weakest base. The D is the correct answer. D is the correct answer. Okay, fine. समझते बुझिए जी? D is the correct answer. Okay. Very important question. Among the following compounds 1 to 3, the each of their reaction with electrophile is. Which one is more reactive towards the electrophilic reaction? Okay, so we can see here OCH3 activates the benzene ring so at ortho and para position okay, so OCH3 is the activating the benzene ring at ortho and para position, increases the electron density on benzene ring. So this one is more reactive towards the electrophilic reaction. Then the benzene will come and the NO2 group is the deactivating the benzene ring because it is a electron withdrawing group. It is a electron group, so it deactivates the benzene ring. Electron density decreases on the benzene ring. Okay, so this one is the correct one. So option 1 is more reactive. Then the benzene will come. Then the least reactive is the your third one, nitrobenzene. So option D is the correct answer. Option D is the correct answer, right? Right, option D is the correct answer. So we'll move to the next slide. Okay, So Bidyasagar Classes in Bhubaneswar, so providing the 36 multicolor printed study material at the rupees 7,000. Okay, so you can, who are interested, fill the form in the Google, okay, description. The numbers are also there, we can contact in these numbers. Okay, we'll move to the next slide. Fine. So which one of the following order is the correct regarding the minus I effect of the substituent? Okay, so minus I effect depends on, okay, minus I effect depends on the electronegativity of the atom. So, you know, the order of the electronegativity fluorine is more electronegative than the oxygen. Oxygen is more electronegative than the nitrogen. Nitrogen is least electronegative. So the minus I effect withdraws the electron from a carbon chain, that is called minus I effect, which depends on the electronegativity value of the atom, which is more electronegative than the hydrogen. Fluorine is more electronegative than the oxygen. Oxygen is more electronegative than the nitrogen. Nitrogen is the least electronegative among the three. So our correct answer is this one. Option C is the correct answer. So where fluorine is the most electronegative, then the OR, then the NR2. So this is the correct option regarding our minus I effect based on the electronegativity value. Based on the electronegativity value. So option C is the correct answer, right? Okay, we'll move to the next slide. Fine. The correct order of reactivity towards the electrophilic substitution of the compound aniline, benzene and nitrobenzene. Okay, so in the first option we have the aniline. This is the first one, aniline. In the second option we have benzene. In the third option we have nitrobenzene. So in case of aniline, the nitrogen is having the lone pair of electron and it will rotates around the benzene ring and increases the electron density. Electron density increases due to presence of lone pair electron. It's more reactive towards the electrophilic substitution reaction because electrophiles are the substances. What are electrophiles? Electron loving species. Electron loving species. So always it will attack to the electron dense center. The species which is more electron density, the electrophiles will attack to that species. Okay. So in case of aniline, because of lone pair of electron on the nitrogen, it will increase the electron density on benzene ring because of plus M effect. Because of plus M effect, that is the mesomeric effect. Nitro group is the electron withdrawing group. Electron withdrawing group. It deactivates the benzene ring. Deactivates the benzene ring. Decreases the electron density. Decreases the electron density. So more reactive will be this is more reactive. So option A is the correct one. Then after that the benzene will be reactive. Then your nitrobenzene. Nitrobenzene is the least reactive because nitro group is the electron withdrawing group. It decreases the electron density on the benzene ring. Okay, so the reactivity of electrophilic substitution decreases. So option 1 is the A is the correct one. Okay, option A is the correct one. Okay, fine. समझते बुझी होची? We'll move to the next slide. Okay, Bidyasagar classes in Bhubaneswar, 200 topic wise test provide korchi, answer with explanation in mobile app. So just rupees 199. We can, those who are interested can fill the form, Google form, description form in the online, and mobile numbers are there, we can also contact. Okay, so we'll go to the next slide. Okay, which one of the following is the strongest base? Which one of the following is the strongest base? So here in all the cases, here if it is, see here, on nitrogen atom, the lone pair electron should be available on the nitrogen atom, so it can easily donate to the other atom or group of atoms, so that it will act as a strong base. If the nitrogen is attached directly to the benzene ring, in case of this one, so in this case the electron density decreases due to resonance. In case of option A, due to resonance, electron density decreases. Electron density decreases. In B also resonance is there. In C there is resonance. In D option, no resonance. So there is electron density is high. Electron density is high on nitrogen. On nitrogen, so it can easily give to the other atoms. So electron density is of your benzylamine. This one is the correct answer. In all other cases, A, B and C, the NH2 group is directly attached to the benzene ring. So in all the three cases there is resonance, so that the lone pair of electron on the nitrogen atom is not available. It rotates around the benzene ring. Due to less availability of nitrogen, the basicity decreases. So basic nature decreases. But here there is no resonance because NH2 is not directly attached to the benzene ring. So there is no resonance here. So lone pair of electron is available on the nitrogen, which it can easily give it to the other atom. So it's the benzylamine is the strongest base. The D is the correct answer. All are getting? Okay, we'll move to the next slide. Which type of isomerism is possible in the compound? Okay, so we'll see here. So this is the structure. We'll draw. Okay, fine. So CS3, CS3, double bond, single bond, COOH, CS3. Fine. Fine. So due to presence of double bond, so see this carbon atom, it is attached to COS group, CH3, this hydrogen, and another this group. This atom is chiral. This is a chiral carbon atom or asymmetric carbon atom. Due to presence of this carbon atom, 2 CH3 group, it is not chiral. It is not chiral. So due to presence of chiral or asymmetric carbon atom, it is optical. It will show the optical isomerism. That is the criteria. The compound having chiral carbon atom is optical. So the optical isomerism. So answer B is the correct answer. Okay, B is the correct answer. Fine. We'll move to the next slide. So Bidyasagar classes at Bhubaneswar, OUAT, provide Kurchi 10 mock test or 2000 MCQs at just rupees 499. So those who are interested, fill the form in the Google description. Mobile numbers are there. You can contact in these numbers. Fine. We'll move to the next slide. Directing influence of the methyl group can be explained on the basis of. So it is not inductive effect. Inductive effect cannot explain the methyl group, directing influence of the methyl group. It is not electromagnetic effect, it will act on the double bonded carbon atom. It is not resonance, it will not show any resonance. It will be your no bond resonance, that is also called hyperconjugation. Hyperconjugation. It is also known as no bond resonance. So the methyl group can be best explained by the no bond resonance is the correct answer. That is also called the hyperconjugation. Okay, the directing influence of the methyl group. Okay, we'll move to the next slide. Okay. So in this compound, the reaction is not possible because which cases? So due to resonance, we'll see here. Due to resonance, the CX bond provides a partial double bond character due to resonance. Due to resonance. So in this case, to break the double bond in haloarenes, it is difficult to break the double bond due to partial double bond character due to resonance. The reaction is not possible. The attack of nucleophiles is difficult. The attack of nucleophiles is difficult, or break the double bond C double bond X, that because of that arises due to the resonance. Due to resonance, the CX bond possesses a partial double bond character. So it is difficult to break the nucleophiles. So the reaction is not possible because of this one, D option. The CX bond possesses a double bond character due to resonance. Okay. So we'll move to next slide. Option D is the correct answer. So Bidyasagar classes at the Bhubaneswar provides OUAT chapter wise notes and the 15,000 MCQs. Answer with explanation at rupees of 249. Okay, if you are interested, then fill the Google form in the description. Mobile number is there, you can contact in this number. Okay, we'll move to the next slide. Okay, so which one is the nucleophilic substitution reaction among the following? Okay, you know, the nucleophilic substitution reaction is mostly carried out by your haloalkane. We know that the CX bond is polar. Halogen possesses delta negative charge and carbon becomes the delta positive charge. Because halogen is more electronegative, it withdraws the electron towards itself. Halogen possesses delta negative charge and carbon possesses delta positive charge. Because of that reason, the CX bond nature is more polar. So it can, nucleophiles can easily attack, because nucleophiles is electron rich. It can easily attack a center which is electron deficient. So the carbon center which is deficient, it can easily attack. So in this case, this is the correct answer. C1, who is a haloalkane, is the ammonia is the nucleophile. So it can easily attack to the carbon center which is electron deficient. Okay, so the option C is the correct answer. Okay. Okay, we'll move to the next slide. Among the following are the most acidic is para-nitrophenol, para-hydroxybenzoic acid, ortho-hydroxybenzoic acid, para-toluidic acid. Okay, so in all the cases, so here para-hydroxybenzoic acid, sorry, ortho-hydroxybenzoic acid so OH group at the ortho position, it will show the minus I effect. Okay, but at the para position, it will show the plus R effect. Okay, so due to minus I effect at the ortho position, due to that is also called the ortho effect. So phenol or OH group at the ortho position will show it acts as a minus I effect group, and that is also called ortho effect. It is more acidic, it increases the acidic strength due to ortho effect. So your phenol or OH group at the ortho position, it acts as a minus I effect group, so it increases the acidic strength, so that due to ortho position, the ortho-hydroxybenzoic acid, due to ortho effect, it increases the acidic strength. So ortho-hydroxybenzoic acid is the correct answer. The C option is the correct one. Okay. So I think so home assignment for this class. So description: decreasing order of the reactivity towards the nucleophilic addition to carbonyl group among the cyclopentanone and 3-pentanone and the N-pentanol is option A 3-pentanone, cyclopentanone, N-pentanol. Option B N-pentanol, 3-pentanone, cyclopentanone. C N-pentanol, cyclopentanone, 3-pentanone. Option D cyclopentanone, 3-pentanone and N-pentanol. Okay, so comment your correct answer in this online. Okay. So we'll meet in the next class, next with a new chapter. Okay, new chapter MCQs. Okay, thank you all for the participation. So please like, share and comment.